rank tensor optimization, low rank tensor optimization with non-local plug and play regularizers for snapshot compressive imaging. For this snapshot compressive imaging, doing which optimization? Low rank tensor optimization with non-local plug and play regularizers. Already have seen. We will see discuss now that result. Here already we know. One side we will see this abstract. The increasing volume of hyperspectral images HSI brings great challenges to storage transmission. Recently, snapshot compressive imaging SCI, which compresses 3D HSI into 2D measurements, has received increasing attention since the original HSI can naturally represented as third-order tensions in this work. We reformable the degradation model in the SCI systems as the tensor-based form, which friendly allows us to explore the underlying low-rank tensor structure of HSIs to address the ill-posed SCI reconstruction problem. We suggest a global low-rank tensor optimization model with non-local plug-and-play regularizes PnP regularizes GNLR GNLR G for global low tensor optimization with N for non-local N alpha and plug and play regularizers to reconstruct the HSI from the 2D measurement, which flexibility and collaboratively integrates three-directional tensor nuclear form 3DTN. That is the three directional 3 T for directional, T for tensor, N for nuclear, and again N for norm. 3DTN, 3DTNN are two implicit non-local regularizers. More concretely, 3DTNN characterizes the global correlation of the underlying HSIs. Two implicit regularizers under the PnP framework exploit the benefits of the transformed space and low rank periods on similar patches of the coefficient tensor respectively. Based on the alternating direction method of multiplex algorithm, we develop an efficient algorithm to tackle the proposed model. Extensive experiments on remotely sensed HSIs and real-world HSIs demonstrate the superiority of the proposed GNLR method. In these numerical experiments, we test the effectiveness of the proposed GNLR. Proposed method here GNLR. Already we have seen GNLR. Okay. Okay. Method, we perform extensive experiments on HSI datasets. The pixel values of all images GNLR GNLR global low rank tensor optimization model with non-local plug and play. That is PnP regularizers GNLR. Method, we perform extensive experiments on HSI datasets. The pixel value of all images are scaled into the interval 0 to 255. The mask H is the shift random binary mask whose kth frontal slice Hk shifts 1 pixel horizontal with respect to Hk minus 1. Comparison methods. 3 comparison methods include total variation based cap TV, NSS based TSI, and Laurent property based NG-meet. The parameters involved in cap TV and NG-meet are tuned to the best performance. The parameters involved in cap and NG-meet is best performance, and the parameters involved in DSA are the following the suggestion of the source codes. The parameters of GNLR are given in the discussion subsection. We use CapTV results as initialize DSCI and NG-meet for pair comparison. Evaluation indices. 3 indices including the peak signal to noise ratio, that is PSNR, the structural similarity index measure SSIM, and the spectral mapper frame are chosen to evaluate the reconstructed results in this article. BSNR is used to detect error between corresponding pixels for example. SSIM defines the structure of the information and reflects the structure objectives in the image. SAM is calculated on each spectral vector averaged overall spatial pixels. We use mean of PSNR, MPSNR values all bands. The mean of SSIM, MSSIM values of all bands, and the SAM is objectively evaluate reconstructed result simulated experiments. The larger MPSNR value, the larger MSM value, and the smaller SSM value mean better reconstructed results. SAM smaller, larger MSSIM, and larger MPSNR. Data sets. 4 HSI data sets are selected, including Pavia, Cave, Harvard, and ICVL data sets. The detailed information of the 4 data sets are as follows. Remotely sensed HSI are selected: Pavia Center and Pavia University. Pavia Center is 1096 cross 1096 images with 102 spectral bands collected by reflective optics system. Reflective optic system, for example, optical system, reflective optic system, imaging spectrometer, optical sensor over area Pavia Center. The submerging size 400 cross 400 cross 80 is used in our experiments. Pavia University is a 610 cross 610 image with 103 spectral bands acquired by the ROSIS 03 optical sensor over the area of Pavia University. The sub-image size 610 cross 340 cross 80 is used in our experiments. The cave dataset comes from Computer Vision Association and contains 32 images. Each image contains 512 cross 512 pixels with 31 spectral bands. The wavelength of 31 spectral bands is from 400 to 700 nanometer with an interval of 10 nanometer. We choose two images, toy and face, as the test images. The Harvard dataset records 50 images from 420 to 720 nanometer with 10 nanometer increments. The spatial resolution of each image is 1040 cross 100 1392 and each pixel has 31 spectral measurements. We select two images, image P0 named cross and image B9 named pin with different textures. The sub-image size 512 cross 512 cross 31 are used in our experiments. Our The ICVL dataset currently records 201 images from 400 to 1000 nanometer with the increment of 1.25 nanometer. The image is with its spatial size. The image is with its spatial size is 1392 to 1300 and the spectral size the spectral size 519. Okay, 519. We selected two images named Ramote 0325 and 1364 named Planet and PGU 0522 1217 named Car with 31 spectral channels. Okay, channels from 400 to 700 nanometer in 10 nanometer increments. The sub images size 512 to 512 into 31 are used in our experiments. Results on HSI HSI datasets. Table 1 reports reconstructed result by different methods. HA datasets reconstructed results by different methods of datasets. The best reconstructed results are highlighted in bold face. The second best results are underlined. Bold face, underlined. We can observe that the GNR method has obvious advantages in MPSNR. Okay, better MPSNR and GNR is better. GNLR in SAM values. For example, the proposed method achieves around 4 TB improvement of the MPSNR value compared with the second